Alright, in this video here we're going to talk about the real zeros of polynomial functions, right? So it's one of a series of videos that I'm doing on polynomials. When we're trying to graph a polynomial, there's a lot of things we try to figure out about a polynomial. The end behavior of a graph, which is the video that I did. We also want to find the zeros of the function, and then also some other things as well, which I'll cover in some other videos that I do. But this one we're just focusing on how to find the zeros of a polynomial, or what the zeros actually mean. Right, so if p is a polynomial function and c is a real number, all of these things are equivalent. C is a zero of p. Right, so when we say a number is a zero of a polynomial function, what that means is that x equals c is a solution of the equation p of x equals 0. Right, so a zero of a polynomial is literally a number that if I plug it into the polynomial, the whole thing equals 0. Right, or it's a solution if I set the polynomial equal to 0 and solve. The numbers that I get are the zeros of that polynomial. Right, now, x minus c is a factor of p of x. Right, so if x minus c is a factor of our polynomial function, that means that x equals c is a solution to that equation p of x equals 0. Think about it, if you hopefully watch the videos that I did on quadratic functions or solving quadratic equations that we did by factoring, when you factor something equal to 0, you separate the factors and you set each factor equal to 0 and then solve. Well, if x minus c is a factor and you set x minus c equal to 0 and solve it, you get x equals c. Alright, so these two things are equivalent. And then the fourth thing up here which is equivalent is that c is an x-intercept of the graph of p. Right, and that's a key one here, like I mentioned at the beginning of this video. When we're trying to graph a polynomial function, one of the things we want to know about that polynomial's graph is where are the x-intercepts? Like, where does that graph cross the x-axis? Right, because that gives us some points that we can put on the graph. So if I want to find the x-intercepts, and basically what all this stuff is telling us, other than that all four of these are equivalent, is that if I want to graph a polynomial, I want to find the x-intercepts. Well, how do I find the x-intercepts? I look for the zeros of the function. I set the function equal to 0, and I solve the equation, and then if I can factor it, I use factoring to solve, and then that gives me my solutions. Right, so when I'm looking for the x-intercepts, I set my function equal to 0, factor it if you can, solve the equation. Right, that gives you your zeros of the function, which are the x-intercepts of the graph. Right, the numbers which make the function or make y equal to 0. Alright, so that's what we'll be doing when we have to graph polynomials, which will be in another video that I do, where we actually go through and find all this information and graph a polynomial. One of the steps in that process will be to find those x-intercepts by setting the equation equal to 0, factoring, and doing all the rest of that to figure out where those x-intercepts are. Alright, so I'm going to pause the recording here, and then I'll erase this stuff and just put up an example where we actually find the zeros of a polynomial function. We won't graph it, but we'll at least see how to apply this stuff to actually find the zeros. Alright, the example we got up here, p of x equals x to the third minus 2x squared minus 3x. I'm just double checking to make sure that I copied that down correctly. Okay, I did. And we're asked to find the zeros of this function. Alright, so again, what we just had up here, there's four things that are equivalent. The zeros of the function, the solutions to the equation equal to 0, x minus c being a factor, and then also the x-intercepts of the graph. So when I'm asked to find the zeros, really what I'm being asked to do is to set the function equal to 0, and then solve for x. Alright, and then if I have to go ahead and graph this, the numbers that I get, the zeros that I find, are going to be the x-intercepts of that graph. Alright, and then we can use factoring, if possible, to solve this equation, which for a lot of polynomial functions, for some of them you won't be able to factor, or the factoring is like supremely difficult to do. For others, it's not so bad. For this one, it's not going to be quite so bad to factor it, so let's do that in order to solve this and find the zeros. So first notice, all three of my terms do have a common factor, which is x. Alright, so the first thing I'm going to do is factor out that common factor of x. And if you haven't watched some of the videos that I did on factoring, I did a whole bunch of them on all the different methods of factoring. Right, and one of those methods is factoring out a greatest common factor, which basically I'm doing the distributive property backwards. Right, if I were to distribute that x back into the parentheses here, x times x squared is x to the third, x times minus 2x is minus 2x squared, x times minus 3 is minus 3x. Alright, so I pulled out that common factor of x, and now can I factor this trinomial that I still have in the parentheses? Well, it's an x squared minus 2x minus 3. Since it's a 1x squared, if I can factor this, it's going to be by finding two numbers that multiply to equal negative 3 and add up to negative 2. right? So if we can think of two numbers that do that, we will be able to factor this, right? And I am setting it up because we will be able to factor this. So what two numbers multiply to -3 and add up to 2? Well, those two numbers are going to be -3 and +1. Multiply to -3 and add up to -2. I'm not sure if I just said that correctly. But that's what we're looking for. So -3 and +1, multiply to -3, they add up to -2. So there's my factoring. And again, if you didn't see the videos I did on factoring, you don't understand what just happened here in these couple steps, go back and watch those factoring videos where I explain in a lot more detail how all that stuff works, and hopefully then this will make sense. All right, so I've got three factors here. I have x times x minus 3 times x plus 1 equal to 0. And so what I do after I factor is I set each factor equal to 0. So I do x equals 0, I do x minus 3 equals 0, and I do x plus 1 equals 0. All right, well, x equals 0, that one's already solved for x. That's x equals 0. Right? That's one of my solutions to this equation. For x plus 3 equals 0, if I add 3 to both sides, I get x equals 3. And then for x plus 1 equals 0, when I subtract 1 on both sides, I get x equals -1. So I have 3 zeros for this function. Right? If I find the zeros by setting the function equal to 0 and then solving, I did that by factoring in this case. So I got 0, 3, and -1. Now, if I were to go ahead and graph this function, which is something we'll be doing in another video that I make, where we do some other stuff as well and kind of put it all together, these three values here would be the x-intercepts of that graph. Right? So the zeros are the x-intercepts, which I get by setting my function equal to 0, factoring if possible, and solving. Right, so that's what was up here before, those 4 different things. Well, those are the 4 things I just mentioned. Finding the zeros, those are my x-intercepts, by setting the equation equal to 0, and factoring. All right? So those are the zeros of polynomials. Now, there's something else about the zeros of polynomials that I'm not going to mention on this video because I won't have enough time to, but I'm going to make another video where we talk about the multiplicity of the zeros, which is another important thing to know when you're trying to graph polynomials. So make sure you check out that video on the multiplicity of zeros, and then also the one that I'll do where we actually put all this stuff together to graph a polynomial function.